going into a paper bag, and it's going for 30 seconds at 3-second time intervals. So the first question that we have to figure out is what are the units of the rate of change? So if we think about what rate of change is, what are we dividing? Slope, okay. But in the slope, what's the numerator? Y values over x values, or dependent variables over independent variables. So can we say what our y values are in this case and what our x values are? Yeah, from our table. So what's our y values? Volume. And our x values? Time. So our units would be? Good. For part B then, we have to calculate the secant. What is the secant again? Okay, the average rate of change. How else do we know it's a secant? 2 points, that's right. So if we look at the first part here, this is the first one. What are our 2 points? What are our 2 time frames that we're going between? 21 and 30. Now, generally when we did these questions, we would sub 21 into the equation and we would get the y value. Do we already have the entire coordinate for the time of 21? Yep, we have it in the table. So we can just copy down those points. So for B, the first point, we have 21, 1, 4, 3, 6. And our second time frame is 30 and 4, 1, 8, 6.7. Yeah? Okay, and there's a few questions yesterday, so I'm just going to label these. So if we have a point, we have x comma y and x comma y. It does not matter which point you say is 1 or 2. It ends up you come up with the same answer because it's all the opposite, whichever way you do it. So 1, 1, 2, 2. And if we continue with the slope, it's y2 minus y1 over x2 minus x1. And what's our y2 value? Perfect. 4, 1, 8, 6.7 minus our y1 value, 1, 4, 3, 6, over the x values, which are 30 minus 21. And so what do we get in the numerator?
305.
And so what does that equal? We got 305 point what? Okay. And what would the units of that be? Good. Perfect. So what answer do we get for the second part between 27 to 30 seconds? 317 point what?
378.
Huh?
378.
378? Yeah. 0.2. And then same, centimeters cubed per second. So we got, do we need help to get that? We're okay? We now have to calculate the tangent at 21 seconds. So previously, how did we calculate it for a tangent? So there's the table values, and then we put our black line at 21 seconds. Whoops. And that's where we're trying to touch. Okay? You guys already mentioned the 2 strategies. You said the one before that we did was we would find a point on this red line really close right in here, and then we would take the slope of that line, because if those 2 points were super close, it would be pretty darn close to what the tangent would be. However, if you look at the scale here, and we look at this point, how are you going to know where that is between them? There's a 500 gap between this scale. It's going to be really hard to find the coordinate of something like 20.9. You're not going to get it accurately. So what's another way we can try to find the slope of this black line based on the information we have? So there's where we estimated the point. So with those 2 points, you're going to figure out what M would be. So what did we get the slope to be? 202.82. Good. And then it's the same problem still, so it will still be centimeters cubed per second. And there's part D.